We are starting to look at 2.3 today. 2.3 is all about factoring. Now, in Algebra 1, what I'm teaching in 2.3 was probably broken up into, I'd say, at least 3 lessons. Because you probably had a factoring with maybe actually 4 lessons now that I think about it. I'm trying to remember. But because you talked about factoring a GCF out. You talked about factoring with product and sum. You talked about factoring what I call product of AC, what I think Mrs. Rogers used to call X method, what she last year discovered slip and slide method, so multiple different methods we could go there. And then we've also got factoring some special cases. Okay, Algebra 2, we did it all at once. So part of the reason that 2.3 takes us several days to get through. Okay, so we're going to go back and look at our factoring rules. Look at some of the basics. So each problem's a little different. We'll have some repeats in here. We'll have some variations. So as we look, and this is just factoring, we're also going to solve equations this chapter using our factoring rules. So, number one thing I'm going to ask though, anytime you factor, and I'm not always great about this, but ask yourself, is there a GCF? What do I mean GCF?
Greatest common factor.
Okay, greatest common factor. Is there any value that I can divide into all 3 terms? X squared, 7x, and 12. No. They don't all 3 have x's, do they? And x squared only has a 1 in front of it. So there's and 7 and 12 don't have anything in common in terms of division. So, what do you guys remember about factoring? I would call this a quadratic trinomial because it's x squared and it's 3 terms. But what do you guys remember about factoring these quadratic trinomials? What do you remember, Ruby? Okay. Unfoil? Reverse foil?
Yeah.
Okay.
Brackets.
Okay. So we're going to put 2 sets of parentheses. Okay. I'm going to specifically use the word parentheses. They're a form of brackets, they're, I don't have the right grammar word here, or English word that, what they're a form of there, but they're grouping symbols. There we go. Okay, what do we know about these 2 sets of parentheses? What's the first thing in each parenthesis? Do we know that? X. Because the first thing in each parenthesis has to multiply to be x squared. So x squared breaks up into x times x. What about my numbers? Thoughts of how we get there?
Doesn't it have to add or multiply to 7?
Mm-hmm.
3 times 4.
Okay. So I call this factoring using product and sum. So if you hear me refer to product and sum, this is what I'm looking for. Product being another word for what? Multiplying, right? So I'm looking for 2 numbers that give me a product of your constant there, your C value. So 2 numbers that give me a product or multiply to be 12. And then what do I mean when I say sum?
Adding.
They add. So 2 numbers that also add to be 7. So you'll usually see me write product and sum. It's multiply and add, right? So now, you guys already came up with a pair, didn't you? Here's my teaching technique for when you get stuck, because there are other times that it's not quite so obvious. There are. My teaching suggestion is think about products of 12. If we list all the products of 12, 1 times what is 12? 1 times 12, 2 times 6, 3 times 4, 4 times 3. I already have that pair, don't I? So I can stop there. So when you get stuck, that's the direction I'm going to take you. But which pair adds to be 7? 3 and 4. And if they multiply to be a positive and add to be a positive, both of them are going to have what kind of signs? Positive signs. So we have x plus 3 times x plus 4. Okay? How can we check ourselves? Can we FOIL it back together?
Yes.
Right? X squared plus 4x plus 3x plus 12. Does this sound the least bit familiar?
Yes.
Okay. This was an algebra 1. I don't know. Did you have to use the 7 in geometry?
Yeah, a little bit.
Maybe on occasion.
A little bit.
Okay. Okay. What about this second example here? What's the first question I'd like you asking yourself?
Can it be GCF?
Is there a value that can divide into all three terms? Nope. 2x squared minus 5x minus 3. No GCF. What's different about this one? There's a 2. Because there is a 2 out front, basic product of AC doesn't work anymore. Okay? So we have to go for a different technique. Now, you guys probably would have had Mrs. Rogers teaching X method here. Okay? I don't know what Mr. Weaver taught, in all honesty, for those of you that had Mr. Weaver for Algebra 1.
I can't remember that far.
Yeah. I don't know if he teaches X method or if he teaches more like product of AC, which is what I've always taught. Now, you guys didn't see Slip and Slide with Mrs. Rogers last year, did you?
I
In
don't know what
geometry?
Slip Slide is.
Okay.
She might have called it something.
She just came across it last year. So she just started last year with last year's Algebra 1 kids, but you guys, unless anyone was doubling last year, you guys were all in geometry last year. So, okay. I think I'm going to stick with my normal product of AC, but then I might introduce Slip and Slide also. We'll see. So, here's the deal. I'm calling this product of AC because we have to consider this A value here. Now, I never wrote this down. AX squared plus BX plus C is the form that these are in, yes?
Yep.
The difference on the first one, my A value is 1. When my A value is 1, I don't have to worry about A. I can just worry about C and B. So, product of AC. What are my A and C values in this problem?
2, 9,
Wait, negative
2 and negative 3. And what is 2 times negative 3?
3.
Negative 6. So I need two numbers that give me a product of negative 6. And they also need to give me a sum of still my B value. Whoops, I just wrote that wrong. Try this again. Okay. That was a product of negative 6. And then a sum of the B value. And my B value is what? Negative 5. So, I'm looking for two numbers that give me a product of negative 6 and a sum of negative 5. What are we thinking here, Tanner?
6 times negative 1.
Does that work?
No, I gotta say.
6 negative 6.
Oh, it's negative 5, yes.
So it would be negative 6 times 1.
Were you guys all sold with the 1-6 combo wherever the signs go?
I thought about the 2 and 3. But
Well, and this is one of those tricky combos that 2 and 3 or 1 and 6, it all depends on the signs.
Well, it couldn't be negative. It couldn't be 2
because
and
it
3.
could
Right.
be negative,
Right.
negative. Because
Okay.
then it would multiply
Yep.
positive.
You guys have valid points. It is not, I agree, it is not 2 and 3 here because it has to be add to be negative 5. That means these would have to be the same sign. That's not going to multiply to get my negative. Okay, so it is a 1-6 combo. Multiplying to be negative means one's positive, one's negative. Adding to be negative means if it adds to be negative 5, you do need the larger number negative. Now, here's the deal. Those are not my answers, folks. No, I know.
No.
We don't get to just put them in the parentheses and stop here. Okay? We have to have a plan B. So, what we're going to do is we're going to take this 1 and negative 6, and we're going to use them to split our middle term. You can either split that negative 5x into 1x minus 6x, or negative 6x plus 1x. It doesn't matter which you put first. Try to look and see if what I want to do here. You guys have a preference? I guess you guys don't really know where we're going with this necessarily, do you?
-6 first.
Negative 6 first?
Yep.
So what I did is I took that middle term, I'm splitting it using the factors of 1 and negative 6, and I put x's on them. Now, my first term carries down. 2x squared is still there. My last term, guess what? Carries down. My minus 3 is still there. Now, we went from having 3 terms to having 4 terms. We're going to take these 4 terms and we're going to split in half. Okay, so right here at the halfway point. And I want to know what the GCF is of the first 2 terms to begin with. So block off the last half, 2x squared minus 6x. What do both of those terms have in common?
They can be divided by 2.
They can both be divided by 2 and
3. No. Okay.
Six.
1.
X. 1. X.
both 2 and 6 divide by 2.
Yeah.
X squared and x both divide by an x. So what we're going to do, and I'm just writing it here for a visual, we're going to divide both of these terms by 2x. But we're going to do this as a GCF. So that means my 2x is going to go out in front of a pair of parentheses. So I want to know 2x, my GCF, I'm putting it out front, 2x squared divided by 2x is what?
X.
X, right? 2 divided by 2 cancels. X squared divided by x. If you have 2 x's on top and you divide 1 away, you now have 1 left. So this is x. Minus. What's 6x divided by 2x?
3.
6 divided by 2 is 3. X is canceled. Repeat the process. Probably should have set this up the other way now that I think about it. That's all right. 1x minus 3. What do they both have in common?
Divided by 1.
If all else fails, the answer is always
1.
1. Okay, when no other GCF fails, 1 and 3 just have a 1 in common. Do they both have an x in common? No. So I'm going to divide both of these pieces by 1. Now that means as I write my answer, what's the GCF I'm dividing by?
X.
No. We're dividing by a positive 1. So I specifically wrote it as a plus 1. You want a sign in there. Is it a plus 1 or a minus 1? It is a plus 1. And then, what is 1x divided by 1?
0. Just
X.
X.
X. Minus 3 divided by 1 is? 3.
This is
Okay, last step.
There's
Okay, so here's the deal. My answer needs to look like this. 2 parentheses.
4.
Now, no,
It's true.
hold on. First of all, what do you notice that happened with our 2 parentheses?
they're the same.
X minus 3, x minus 3, yes?
Yes.
They're the same. If they're not the same, you made a mistake.
Oh, I remember how to do this.
Okay, if they're not the same, you made a mistake. So, they're the same. That's good, yes?
Yes.
That is half my answer. Okay? The x minus 3 in common is half my answer. If I take that x minus 3 that was in common away, what are the remaining pieces?
2x plus 1.
My GCFs of 2x plus 1. Now, that's not the only way to do this problem. But that is what I call product of AC. Okay? Yes, Paul?
So on whenever you divided it by 1,
Uh-huh.
why did you tag an X on it? Is it because the other one just had
Right here?
It's 2x, because it's x squared.
Okay.
So you take it, you divide it by x, you take one of the x away. On the 1x, there's no
square?
Alright, so there's no extra x's to take away.
I don't like this. I don't want
Go back to graphing.
I agree.
Go back to graphing.
No,
You didn't
I
do
hate
graph.
graphing.
You know what?
This sucks.
You guys, wasn't it Jaden that just complained about graphing
Probably.
like earlier this week?
Patrick. It was
Patrick?
Patrick.
Hate to be that guy.
I think it's weird.
Okay,
There's no form.
Need to be honest.
there's no formula?
I mean, there is.
Yeah, let's
There is, there's a process.
Let's do something where we plug and go.
Okay,
Alright, we're done for the day.
nope. Okay. We'll come back to this process, okay, when we need it next time. I'm just doing several different factorings here. Okay? So, we've got some factoring here, we've got some product of AC. Let's try this next one. 3x squared minus 18x minus 48.
You see it.
About a 1.3.
Is there a GCF?
Yep.
Okay.
3.
And what I can guarantee Ruby just picked our calculator up to check is, does 48 divide by 3?
Yes.
Okay, so, step 1. We're going to factor that 3 out front. So take every term and divide by 3. Now, the 3, did you write it out front? Okay, you have to. 3x squared divided by 3 leaves me with x squared. Minus 18x divided by 3 leaves me with
6x.
minus 6x? I'm not sure I ever heard the minus. Maybe you guys
It
automatically
was
assumed it.
implied.
Okay. Minus 48 divided by 3.
Negative 16.
Okay. So, there's an example with a GCF. Am I done with this problem?
Yeah,
Oh,
we
no.
got- no, we gotta get 2 points.
Not necessarily. You need to check and see, does this factor into 2 parentheses? So, the 3 stays out front. Now, do I have to use product of AC on this problem? No, because what kind of x squared do I have now? I have a 1x squared. Can I go back to problem 1 and use that technique?
Yeah.
Does that make us happier?
Yes.
Okay. So, x squared breaks into
2 x's.
x times x. Now, this time, I need numbers that do what?
Multiply to negative 16 and negative 16.
Okay, so we're looking for numbers that multiply to be that end value, that C value, negative 16. And then we want those same numbers to add to be my middle value, which is negative 6.
8,
Does an 8-2 combo work?
negative 8, 2.
Okay, so if I start listing products of 16, 1 and 16, 2 and 8, 3 doesn't go, 4 and 4. Those are my options. The pair that's going to work here, 2, 8. If it multiplies to be a negative, I need one sign to be a negative. Which one did you guys say is negative?
8,
8, because negative 8 plus 2 is
negative 6.
negative 6. What do I do with that 2 and that negative 8?
Put positive on one of them, negative on
Yeah. You put x plus 2, put the plus 2 in one parenthesis, the minus 8 in the other parenthesis, and guess what?
It works.
We're done.
Oh, so we don't. Doesn't matter if you put the plus.
That's only if it's a x squared plus b
Okay,
plus c.
so multiple questions here. The whole parentheses being the same is when I had an a value and I did product of AC. Okay, this one, we didn't have an a value once we factored the 3 out, so x squared, you just break it into x and x and come up with your values.
So if we can't, so it's the one that we used, that they were the same, we didn't use the least common, we didn't divide them like the original problem.
We couldn't divide it by anything,
Right,
right?
so that's how you know that.
Does it matter which order you put your parentheses in?
No.
No. I would definitely put the 3 out front, but if you said your answer is 3 times x minus 8 times x plus 2, you're good to go. That's equivalent. Okay? Now, x squared minus 9.
square root of 9.
Hear me out, right?
X equals 3.
Hear me
No
out, right?
solution.
No, still.
No. Hear me out. They just gotta add, or they gotta add 0.
X
So it'd
equals
just
3.
be like -3 and 3.
X equals 3. Plus or minus. Oh,
I'm checking now.
Okay.
Oh, God.
Now. Okay. I'm hearing some good stuff. Because when you guys are recognizing, I heard square roots. I heard something about square roots, right?
Yeah.
That's a good thing. This is officially what we call this is difference of squares. Because here's the deal. 9's a perfect square, isn't it?
Yeah.
And can you take the square root of x squared?
Yes.
Yeah. Those are both perfect squares. So, what is the square root of 9?
3.
It is 3. Okay?
And that's
We're going to have to talk about plus and minus here. What is the square root of x squared?
X.
X. So here's the deal, folks. X squared breaks into what?
2x.
X times x. Square root of 9 is
3.
3 times 3. If it multiplies to be a negative, how do numbers multiply to be a negative?
One of them has to be a negative, the other one's a positive.
Oh,
One positive, one negative. Now, could this support the idea of two numbers that multiply to be -9 and add to be 0?
Yeah.
Yeah, because do we have an x term? No. We don't have an x term. There's like a 0x in the middle. You can think that way. I just say it's difference of squares. When you see two numbers or two values being subtracted, they're perfect squares. You can take the square root of them. It's x plus 3, x minus 3. And here's the deal. If you FOIL this together, I have x squared minus 3x plus 3x. What's a minus 3x and plus 3x going to do?
Cancel.
They're going to cancel each other out. Minus 9.
that's one of my speed.
Let's go with
And that's the one that usually is a struggle because
this one's
it's a special case. I agree. Okay, now here's the deal. It's an easy one as long as you can identify it what to do with it when you see it. Okay? Okay.
I got an idea what we need to do for the next one.
You got an idea of what we need to do for the next one?
We need to do that.
Question, or are you on the next one?
Is there any way, like, on these problems where there is no solution? Is that like,
There is technically the possibility that they do not factor.
okay.
You're not going to see any like that, though. Does that answer the...
She got us covered.
Because I wouldn't know if I'm making a mistake.
Ruby's really wanting this no solution possibility.
Well, sometimes those solutions are complicated, so is it?
Yeah, no. So the no solution would be if you find a situation where you have a product and some you need and those numbers don't exist. Okay? Then it is possible that it does not factor, would be our variation. But everything I'm giving you is going to factor. Okay? Okay, guys. 3x squared minus 7x plus 2. What are you thinking about 3x squared minus 7x plus 2?
We got to do the ax squared plus bx plus c.
Okay. Is there a GCF?
No.
Unfortunately, no.
Usually-
Which means we have an a value, don't we? So when we're in that form, ax squared plus bx plus c, and there's no GCF, we need a product of AC. What is A and C here?
3 snakes.
When I asked A and C, think of the form ax squared plus bx plus c. A and C are 3 and 2. 3 times 2 is 6. We need a sum of the B value. What's B? -7. What multiplies to be 6 and adds to be -7?
-1.7.
Negative.
Well, let me throw out there the options that multiply to be 6 are 1 and 6 or 2 and 3. Which pair is going to add to be 7?
Negative.
1 and 6. If it multiplies to be a positive, realize your signs are the same. Both positives or both negatives. Okay? What do I do with this negative 1 and 6?
Split your 7.
Since we're doing product of AC, we split that middle term. And I'm going to split it into minus 1x minus 6x. Could you do it the other way and it all works out in the end?
Yes.
Yes. Take the first term and bring it down. Take the last term and bring it down. We have how many terms? We have 4. Split it in half. GCF of the first half. 1 x. And here's a hint. Your first GCF will always include an x because you'll always be taking from an x squared and an x. So this is 1x, or can we just write x?
Yep.
You can. And that means I'm taking those first 2 terms and I'm dividing by x. There's my visual for you. 3x squared divided by x. 3x, the 3 stays, one of the x's cancels. Minus 1x divided by x. Minus 1. Because an x on top will cancel the x on bottom. So minus 1. Second half. Why negative 2? Yeah. Here's the deal, guys. Anytime this first number is negative, you're going to want to use a GCF of a negative. I think we can all agree 6 and 2 both divide by 2. Because that first value is negative, we have to divide by a negative 2. Now, did you write down right here in the middle? Minus 2, because that's what I'm dividing by. And then negative 6x divided by negative 2 is 6x divided by 2, 3x. Negative divided by negative is positive. Plus 2 divided by negative 2, minus 1. Did my parentheses match?
Yes.
That's good news. That means all I have to do is write down my final answer now. Final answer is always 2 parentheses. One of the parentheses is the matching set. So I'm going to pull, and it's just 1. You're just pulling the 3x minus 1. It's kind of like a GCF. It's the GCF of the 2. You just use 1 to represent it. And what's my leftover pieces then?
X minus 2.
There you go.
I remember reading that. Yeah.
Okay. One more problem.
I think we did that now.
This?
That method, yeah.
Okay. Oh, with me, we would have had Mr. Weaver. Okay. That's I don't remember what he teaches. So, but now, did you guys have Mr. Weaver's first year here? No, you guys had him the second year here, didn't you?
Aye.
Okay. Okay. Last problem of the day. GCF.
And divide it all by 2.
Ooh, should we do that?
Yes.
We definitely should, huh?
Yep.
So if I'm going to divide everybody by 2, don't forget that 2 has to go out front, yes? 2x squared divided by 2 is
X squared.
4x divided by 2
2x.
minus
63.
Okay. Am I done? Do I call it quits?
Yep.
No, we gotta get 2 prints.
Now, is there a chance you might be done here? You've done all the factoring you can. There is a chance. There's a chance that we're not going to be able to get product and sum to work and we stop here. However, more likely is the story that you can continue. Okay, now do I have to do product of AC?
No.
No. Because this is just an x squared, now we're going to keep the 2 out front, but because this is just an x squared, we're going to break it into x and x. Okay? What numbers are you trying to multiply to get?
Negative 60.
-63. What do we want them to add to be? 2.
It's probably -7.
So that's what it
Okay? If you list your pairs for 63, what? 1 and 63, 2 doesn't work, 3 and 21. If two, the even number doesn't go, no even numbers go. So skip 4. I know 5 doesn't go. 6 is even. 7. 7 and 9. Okay? How did you make the signs work with 7 and 9?
-7 plus 9.
-7 plus 9. Because a negative times a positive is a negative, and it adds to be a positive 2. Okay, guys. We're going to call that the stopping point. 6 minutes.
It's not.
Use it if you need it. I know.
It's not enough.
I know. Sorry.
Very true.